Assalamualaikum and good evening to everyone. Thanks to Izzat for the explanation. Now, I will be talking about the flame ionization detector. The flame ionization detector is almost universally employed, where the flame commonly is generated with hydrogen and air. Plus, the flame ionization detector is very sensitive with a very low limit of detection and a wide dynamic range. Then, flame ionization detector is a mass sensitive where the more carbons in the analyte, the lower the limit of detection. How this detector works? So, the autosampler provides the means to introduce a sample automatically into the inlet. Also, manual insertion of the sample is possible. The column inlet or injector is attached to the column head and provides the means to introduce a sample into a continuous flow of carrier gas. In the injector, a sample is introduced into a heated chamber via syringe through a septum. The heat facilitates volatilization of the sample and sample matrix. The carrier gas then either sweeps the entirely splitless mode or a portion split mode of the sample into the column. In split mode, a part of the sample carrier gas mixture in the injection chamber is exhausted through the split vent. Then, splitless mode, all the sample carrier gas mixture in the injection chamber is transported through the column. The mixture separation is based on the differential portioning of the components between the mobile and stationary phases. The component which has less affinity to the stationary phase, consequently less interaction, travel fastest and dilute out first, and the component which has more affinity to the stationary phase, consequently more interaction, travel slower and dilute later. In addition, other factors influence the separation of the components, such as column temperature, carrier gas flow rate, column length, and amount of material injected. As compounds value from the column, they interact with the detector. The operation of the flame ionization detector is based on the detection of ions formed during combustion of organic compounds in a flame generated by hydrogen and air to detect these ions. Plus, there are two electrodes, which are positive and negative electrodes. The positive electrode works as the nozzle head where the flame is produced, while the other negative electrode is positioned above the flame. When an organic compound is mixed with the hydrogen flame, the cations are generated and a current is produced between the electrodes proportionally to the number of organic compounds present. This current is measured with an electrometer amplified into proper voltage and fed into an integrator. That's all for me. Thank you.